Welcome everyone to another Let's Talk After Work episode. I did something similar already, probably some 6 months or so ago, when some fellow YouTuber here, Theo from T3GG, postulated previously perfect code is bad, my previous video, right? I continued to disagree, and I wanted to make this video already for quite a while because I also saw this here on YouTube, because some months ago already Theo said why they don't unit test, and as usual, as with perfect code, explains why that is the case. Let's quickly watch it a little bit, and then I will add my 2 cents and agree why I think unit tests is highly important, and then let's discuss it. So let's first give them a word and let's see what they say.
Let's talk about unit tests and why I don't use them. I know that's a bold statement, but I don't have much a use case for unit tests in the vast majority of the things that I build. And I think that when I say that, my take gets seen as some crazy rebellious person who only works on small teams and is more than happy to take that funny.
So I fast forward a little bit, right? It's basically, you can obviously watch it. I don't want to restring here all this 8 minutes.
Enough. Some other big companies have. One of my favorites, and I need to go find the tweet quick. Here, wanted to go find this tweet because, as I said, it's a banger. Somebody went on a rant about like eng culture coming from one company to another, and
so yeah, previously Facebook not written in 5 years unit test, and it's cheaper to test in production. Test in what could possibly go wrong in a test in production? And
Facebook
forward.
engineer, they like if you're doing like financial bank software to make sure transactions are being processed correctly on the back end.
And so here already disagree, right? I basically don't need to watch it. If you want to watch it, then watch this video. So he says that basically also they somewhere say their average time to fix stuff or push fixes or something 7 minutes. I totally don't believe that, right? If I'm very good in my 20 years of professional software engineering, and sure, sometimes I find fixes quickly, but often I need to debug an hour. Sometimes I even need to debug 8 hours in GCC stuff, right? And also financing, right? No, I would argue you basically, for everything non-trivial, you want some kind of unit testing, because, for example, even image processing, data processing, right? JSON, XML, it's not only financials where you might lose millions or whatever when it disappears from your account and payment transaction stuff. But so why is it cheaper, right? So so not only is it cheaper, of course unit testing should be reasonable, and somebody said 100% code coverage. I would actually agree, you don't necessarily need 100% code coverage, at least not when you're not doing financials and flying to the moon. But I would argue you should have most code coverage, or like maybe 75%, or let's maybe call it 80. Why is it? Because everyone knows it, you test it, it works, and then other people or you keep changing it, right? And then you might break stuff that you don't even test it, right? So basically, if you don't have unit testing, every developer needs to test manually themselves, and I've actually done that previously in the beginning of my career. I remember when I took Mini SED, the GNU SED implementation, over from Eric S. Raymond, also didn't come as a test suite. And like initially I fixed some stuff in SED, and I sometimes broke other stuff, right? Because obviously I didn't, even Mini SED was only 2 C files, obviously a little bit vintage C files and stuff. But case in point, you change stuff and you break other stuff, right? So after like breaking a couple of things in Mini SED in like 2005, I started to create the test suite, right? Actually, I could show you that. Nothing like some live test suite here. So we have Mini here. And so how does it look, right? It's how did I run? Probably SED or stuff. And so this is with SED. So, and this is super easy, right? And so what does it allow you? It allows you, when you make changes, like future changes, like you and every other developer can test this stuff, right? Because, and there it is cheaper. Sure, you can put there some graph with scripting some stuff, and it's like scripting initially, you do it once, then of course scripting it, it's more expensive, but like basically you do it a couple of times, like which you would always do. And like basically after this third or fourth time, it is already cheaper, right? How do you want, I would actually argue, you cannot develop any non-trivial software, and actually SED, regular expression, is already non-trivial software without a proper test suite, right? Also for you adding new features, right? So often people, and I see this, I already have the slogan, you can actually order in our YouTube merchandise store, right? The only constant, if you want to have a nice hoodie or stuff, t-shirt, the only constant is change and regressions, right? If you are not testing it, and I say this so often, even with my own code, others people code, the second thing is, what is not tested is broken. This is like rule number one, right? Have you ever written code that you wrote the first time it was working like intended? No, of course you need to test it. And what is the most natural thing when you test new code to write a test suite for that? So, but not even SED. Also, for example, our exact image, although this test suite is not public. Actually, the mini SED test suite is public. I believe that is part of the sources, as far as I remember at least. The exact image test suite of our GPL, better than ImageMagick, written C++ stuff. The test suite is however not public, but it is similar to our mini SED, which also started probably around 2006. And there is a similar thing, like image processing. Basically, I only want to give you this example that you need unit testing. Like it is cheaper, especially in the long term, to develop software with unit testing, because then you can quickly test stuff. Like here, right? What is broken? So this was so wrong. So basically, I tested our mini SED suite against GNU SED. The other is actually, I have a user as a SED or no failure. Because even I, as master Jedi programmer, as I often appear here live on YouTube, and even I break stuff, right? Case in point, just the other month, I've broke some of our T2 scripting. And actually, I would argue I said this so often. And actually, I started already on More Life channel. I actually started to do some unit testing on our Linux distribution. If you're new to this channel, you run a whole Linux distribution. And I have to admit, our Linux distribution is like the only thing we don't have lots of unit testing yet. And even there, it shot myself into the foot already. I remember 2003 or so, the GNU find utils had a regression, because we obviously use all the Unix tools here in our Linux distribution for this embarrassingly massive shell scripting. And I remember that there was, because obviously, right, what is not tested is broken, and the only constant is change and regressions. Even the GNU people, the GNU find utils people, had a new bug in like around 2003, where we had some massive find name, prune, directory stuff, like 20 predicates or something. And like some, I think, prune directory, it's 20 years, I can't remember each detail, but as far as I remember, like some release of GNU find utils broke like prune directory or stuff. And then I deleted most of my sources, right? I run here some commands of my Linux distribution 20 years ago, and it's like, why does it take so long? And then Control-C, and it's like, shit, half of my source tree is gone, thank you very much, GNU find utils. But even here, the other day, we have some super smart optimization. And I did some trivial changes, and only today I noticed, what is not tested is broken, right? The only constant is change and regressions. And I broke my own stuff, right? We have here some smart database of file-based smart profiling of whole Linux distribution stuff, so that we can compile everything for size to best fit into CPU caches, and only optimize hot files with the most optimizations we could throw at it. At times no other Linux distribution does it like that. And only today, by pure chance and accident, coincidence and stuff, I actually realized that I broke it, right? Because I was wondering, I was adding some new profiles, and I was wondering, wait a second, like just by pure, this is testing, right? And if we would have my own point, right, which also reminded me, actually I wanted to do this video for quite a while, what is not tested is broken, right? I did here some improvements, and actually this is kind of performance optimized. It's the only thing I did here back in the day. I changed here, like, because this is removing the prefix from path file names. and only leaving the pure file name. And like I micro-optimized this wrong, right? And I obviously tested this lightly, that my micro-optimization did work, like testing it once. And that's the thing, right? If I test, like I or anyone, if you test something once while you're developing it, does not mean like all the other 70 or so code passes still work, right? It turns out, darn, I actually freaking broke it for all. So I didn't break it completely, but that is the thing, right? That is exactly what unit tests are for. I optimized it, among other things, and broke half of the cases where file names did not. So because I moved this here into this if clause, like if we substitute something, it's like basically due. Only months later, I realized, only because I like was by pure chance accident and the moon is in the right spot and stuff. It could have been years, right? If I would not have been that lucky today, it could have been years until I realized, darn, I broke it. Thankfully, it was only months, because I moved this into the if clause. That means if we are not removing trailing, leading path directory prefixes here of the file name, then we don't match this in this associative array anymore, right? And so even for shell scripting, right? So basically in the future, the problem is that our Linux distribution is really large and like a really extremely diverse code base, like not like just some SED. I also hit the wrong button here, darn. Excuse me. Hope it wasn't stuttering, I accidentally clicked record. So yeah, in our Linux distribution, it is much harder to unit test. I mean, sure, everything's possible, but so it's certainly much more complex to test here all kinds of various things. But like if it would be, I mean, increasingly it is a enterprise-ready high-end Linux distribution. But if it would be more than a hobby, which probably soon it isn't anymore, we need unit tests, right? I'm totally aware of that, because if you don't have unit tests, you have, even if you're alone, you break stuff. Even I broke my own stuff. And if you have more, it only gets worse. And then people also don't remember, right? You optimize stuff 10 years later. And the thing is, you don't have test vectors, right? Without unit tests, as I said earlier, you always need to reinvent the wheel, right? You work on whatever, even pixel data, right? So exact image, what kind of tests do we have? We have tests for blurring, matrix convolution, other algorithms, brightness, contrast, gamma stuff. Because the thing is, it can even be a compiler breaks it, right? You write modern templates, doesn't even matter. Modern C++ or old-fashioned C code, doesn't matter. It can even be compiler bugs. It can be floating point numeric bugs. It only sets either numerically unstable or whatever stuff. It could be so many things. Of course, you change base class data layout and stuff or whatever, which causes problems in other algorithms and so on. And so in the reason that exact image test suite is not public is because it also contains client data and other things, and also tests for algorithms that are not part of the GPL release, because we use it also part in our professional products. I don't want to give our competition all the test data, including it. So the test suite, we are our small company here at Extracode. And we're not even bigger than this T3GG or whatever that is. Because I'm totally aware, right? If we don't test it, it's broken. What even was there? Yeah, T3GG. Because like autocropping, right? What do we have there? We have the raw scanning data of scanned paper. Even testing, so we are even testing our auto-cropping algorithm, we're testing barcode recognition. Obviously we have tests, we have hundreds, maybe approaching 1,000 unit tests for our OCR. So there you see, it's not only fine engine, it's not only a nuclear power plant, space, rocket science, self-driving cars and stuff. No, you want unit tests for everything on travel, be it your Linux distribution, your image processing, your sound processing. Because imagine like speech recognition, right? You don't want to randomly change stuff and then it doesn't recognize stuff anymore. You don't want to randomly change algorithms. You can even benchmark this, right? It's not only numerical stability and like loading image data, saving image data, processing image data or sound or other financial data, but even performance, right? You can also use this. I mean, obviously, if you write a Hello World example website, like, yeah, and maybe you don't have so much to unit test, but even if you write a high performance web server, you want to also performance test it, right? So in this unit test, either you, and profiling, right? So either you wall clock time, like you work on algorithms, you make stuff more efficient and stuff. Either you can even unit tests, especially with synthetic, modern, amazing open source projects like QEMU and similar such things. You could even cycle count this, right? It's much easier, at least like when professionals like I do this, often unheard in the Windows world, because the problem is with performance profiling, if you run this on everyone's PC, you have different cycle counts, right? Actually, pro tip, so if you are serious with performance business, you can run this a little bit slower through QEMU and have, or similar such virtualization solutions, and have actually reference like not clock speed and turbo boosting and so on, and microarchitecture, different performance characteristics, but can run this and count real instruction cycles. By the way, amazing pro tip here, free mixed into this. So benchmarking and then also profiling, right? How do you, if you don't have a unit test, and someone like either your customer or your boss tells you to profile, like you need more performance because performance, then if you don't have a unit test, you each time need to create new test cases, right? So if you're professional unit tests, then you just have them at hand to also do performance work, right? Profiling that with Valgrind or other Linux-based, other less professional operating systems, performance counters and stuff, cache misses, branch mispredictions, and so on, or new optimization using SIMD, single instruction multiple data instructions. Nowadays, people even optimize the XML or JSON processing with SIMD, AVIX 512, and so on. So yeah, don't believe all random YouTubers. There is so much misconception out there, from perfect code is bad to don't unit test, like no. Don't believe everyone's random opinion. Get some various inputs, listen to some professionals, and perform some common sense, right? Think about it yourself. I mean, I came, when I was a junior programmer and new in this open source, and I took over mini SED, like it only took 1 month. Like I fixed some stuff, I had some regression, and like I have 1 regression, I have 2 regression, latest at the 3rd regression I thought, okay, I'm not going to stable maintain a regular expression engine in many SED vintage C code with all the freaking unit test suite. So yeah, I hope this helps you. And it's of course easiest if you start a new like if you start a project, it's always easiest to also start unit tests, right? If you do image processing. By the way, another pro tip: many of these things this test is also super slow at times. No, the input actually. Do I have here input or? Some of this input data. Why did it not list in? Whatever, I mistyped there. Some of this test is some of this test input is super small because let's see, because I actually use synthetically drawn stuff, for example letter J, so that of course helps when you can load ASCII encoded portable animate data. Another pro tip, the second major pro tip: you don't need massive data. You could even, some of our unit tests are just 3 by 3 pixels or stuff. That is usually enough to test your algorithm, and it's much easier to debug, right? You can even ASCII diff this stuff, so your test suite can, you could even theoretically do this with audio data with waveforms, but probably there it is a little bit difficult. Of course, lots of data. We also have test suite for loading TIFF, JPEG. Like basically each time a customer comes with some not supported TIFF file or not supported JPEG file, that's also another pro tip, right? the third major pro tip probably for this video. Each time you have a bug or a performance or incompatibility, marginality, at the test case, right? That because otherwise it will break later. Basically, I would also say everything not tested is either broken or will eventually be broken due to other changes. So when you fix or add something, my recommendation would be, as I said earlier, I would agree, the only thing I probably would agree with Theo here is you don't need 100% test coverage, and 100% test coverage is actually super difficult and expensive. 100% test coverage would be like covering every branch in your program, which would be ideal. Like if you fly to Moon and Mars, probably, then like for rocket science, I would probably recommend 100% test coverage. But for non-mission critical, I would actually, as I said earlier in this live stream, 80% TISH are probably okay. But if you fix, improve on whatever something at the test case, because you need to test it anyway, right? So if you test it already, fixing or implementing something at the test case, so that you not only document and know that this is working now, but also for everyone in the future working on it, that they can test and make sure that it will still work. And this will actually save you so much money, because I don't believe that the average fixed deployment time is 7 minutes or so, because I'm 25 years in this industry and I've rarely seen bugs fixed or fixes deployed in 7 minutes. So that smells a little bit fishy to me here through YouTube, smell-o-vision. In my experience in non-travel code, bug hunting usually takes longer than 7 minutes, sometimes hours and sometimes days. I've seen it all, especially the closer you come to operating system. And just look at GCC Clang, how many test cases they have, and that is how many you need. And what, last but not least, I actually wonder that the Linux kernel doesn't have more tests, because if I would write a new operating system from scratch nowadays, I would actually also do test suites, right? You can, what the Linux kernel is not doing, but theoretically you could test suite all kinds of memory layouts, even drivers. You could have at least hardware register maps like IO spaces. You could even have ASCII maps, so that you have test suites for all kinds of hardware state and testing your driver, like compiling. I mean, in my microkernel, obviously much more elegantly than in the Linux kernel, but even the Linux kernel, you could either with special instrumentation or a special, like, think user mode Linux header setup, so that you can compile this without, like, in kernel use, at least test parts of the driver state and so on. Because even I so often seeing NDNS bugs, right, you could test USB structures, USB protocols, a human interface device, things like basically everything not tested in the Linux kernel, even network, right? Sync network, you could test also with network kind of dumps and so on. You could have all those protocol bits and pieces in test suites, and actually before, like, randomly testing it and booting it in a virtual machine or real hardware, run your make check on your operating system and have all the tests you previously implemented actually verified that they still match. Again, with compilers, right? So many bugs, recurring theme, right? As seen already 100 times, and in real life, obviously more. New compilers over, like Linux kernel, right? So many times over optimization. Also, like, stuff that just accidentally worked, right? New compiler optimizes stuff more and stuff breaks. Even compiler bugs, right? So often, just look at the Linux kernel. I mean, not only use after free and out of bounds and stuff, which lots of stuff, not only you could fuss, but unit test, but also so many changes of new compiler optimizes stuff more, or previously it was just working by pure chance accidents, and architectures, right? NDNS ports to other architectures, think RISC-V, little versus big NDNS, lots of stuff. And if you then have test suites for hardware, register, memory map, IO spaces, and file systems, right? I really wonder, I mean, maybe they have some unit tests for something, but I checked actually recently and was surprised that there's still not a major set of unit tests in the Linux kernel. But yeah, just an idea, just wanted to put this out additionally. I hope you enjoyed this and learned something. Let's take a quick look at the comments. And as usual, don't forget to share, like, and subscribe, and also to our more random channel where I usually have more development and live discussions. So Xdal, which just I don't see my... And yeah, also another thing, browsers, right? Just look at your favorite browsers, how many unit tests they have, and so much. And I mean, again, I could seriously completely, this is where I'm shocked always. Why do I make these videos? I'm random videos are recommended, popular, right? Other popular YouTube videos recommended to me, and I sit here, oh man, why do they do this to their viewers? Xdal writes, test is especially important if other people use your code. Yeah, even I break my code, right? I always sit here, I always blame other people. If the only concern is change and regressions, like change and regressions, I manage to break my own code. And that's for DevOps comes in, works on the machine no longer, things in 2023. Yeah, I think he also somewhere there mentions he hates DevOps and too expensive for stuff.
Should probably have unit tests. Building applications for users is almost always cheaper. And if
No,
it's not,
it isn't. Just no, it isn't. I mean, again. I would even argue, sure, by the way, I would argue you need to make test suits easy. Like, look, and this is why, sure, you could argue I have a low quality of stuff, a low code test suite, but I love simple stuff, right? And I'm not using JUnit or whatever unit systems are like, no, I just use some shell scripts with data input output stuff. I also hate overcomplicated unit testing stuff. Just make unit testing as simple and elegant as possible and super easy to use, or even fun to use, right? Sure, unit tests needs to be as simple and easy as possible, that they are not annoying to work with. I've seen so much stuff that is annoying to work with. Yes, that is, as the name implies, annoying, man. I don't care how you unit test, but unit test. And as I always say, what's not tested is broken. Fantafin writes, Android systems just nightmare. Needs like every major manufacturer device and OS version. Make sure things work on each one due to all variations. Latest Telegram upgrade has made the app crashing. Yeah, and that's also why we can't have nice things, right? Because everything is broken. This is the reason I know Apple has test suite, but still so much stuff at Apple is hashtag peakbugs, right? The hashtag I introduced many years ago, probably 5 years ago, because that's what happens year after year, like with big companies. Think Windows, right? Of course, Microsoft had no unit tests when they started copying their quick and dirty operating system, and then copying the windowing system and writing everything from scratch when they were still working out of their garage somewhere there. And it shows, right? The whole base of Windows 32 subsystem full with bugs for decades, security vulnerabilities. Sure, in the meantime, Microsoft for decades has unit tests, but if you start with a quick and dirty code base without unit tests, that's what you get. And unfortunately, the same creeped into Apple with questionable design first and code second. And I know I'm aware Apple has unit testing, but apparently not enough. That's probably when you only unit test half, or when unit testing is difficult and annoying. I don't know what kind of code coverage they have, but given the amount of bugs in macOS that I personally see on a daily basis, my impression is they don't have enough unit testing. Stopped trying to correct others some time ago. Majority of the case it does not work from their point of view. Waste of the time. To understand something, you have to have the ability to do it. This is based on your personal experience. If someone's programming without unit tests didn't burn themselves significantly, he will not understand about talking. Yeah. Happy to read these comments. Again, I hope you enjoyed this and learned something, and I hope to see you soon for all the next fun stuff to come.